What we're going to look at here are 5 of the most common parent functions that we're going to encounter. There's lots of functions that we could graph. Different years or different teachers, you might do different functions. So we're just going to look at 5 common ones that we're going to work with right now. So what is a parent function? A parent function is the simplest version of a function. There's no transformations on it, right? So that's what I got written right here. So let's start with y equals x squared. Y equals x squared is a quadratic. We've hopefully seen this one before. So let's plug in some key points. So how about -2, -1, 0, 1, and 2? We could sub in any points, but those are some common key points. Now, what we're going to do is we input those into x, and then we square, which squaring is our function right here. That's what it's doing to the x, right? The function is what is happening to our inputs. We're squaring them, so our function is to square it. So you square a -2, you get +4. Square a -1, you get +1. Square 0, you get 0. Square 1, you get 1. Square 2, you get 4. So let's put those on our graph. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And we get our parabola here. Now, if you want to complete it, you could also throw in the 3. 3 over 9 up, because if you square 3 and square -3, you get a +9. And we get a curve that looks like this. And that shape is called a parabola. So I'm just going to write the shape name down here. That's what we call that kind of curving arc. Parabola. Okay. What's the domain? We can input anything we want. So I'm going to say x belongs to the set of real numbers. And the condition on the range, I'm only going to write the condition part of it. The y's are greater than or equal to 0. Now, this little thing I've written underneath each of the parent functions, the family of functions, we're going to discuss that later. But this is something you can look back to. So the family are once we've applied transformations, once we've done stuff to these, moved them around, stretched them, compressed them, flipped them, reflected them. So we'll hold off on talking about that later. We also call those the children or the family members. These are functions that have been transformed. So for now, we're just looking at the parents. Let's do the next one here. All right, so we're going to look at what's called the cubic function. Why is it called cubic? Because you cube the inputs. So whatever we input into x, we are going to do to the power of 3, cubing it, cubic, right? So let's input the same numbers, -2, -1, 0, 1, 2. Those are just good numbers to start with. They're all hanging around the origin, hanging around 0. All right, so if I put -2 and I cube it, -2 times -2 times -2 is -8. -1 times itself 3 times is -1. 0 times itself 3 times is 0. 1 times itself 3 times is 1. And 2 times itself 3 times is 8. And we end up getting this. So let's plot these points. There's a 0, 0 in the middle, so we're kind of overlapping our quadratic from before. -1, -1 on the left, and -2, -8 also on the left. So what it makes is it looks a lot like our parabola up there, and it has that kind of parabolic arc to it. But on the other side, 1, 1 is a point, and 2, 8 is a point. So it's got another half of a parabola heading the other way. So we could somewhat describe the shape as 2 halves of a parabola. But they're going in different directions. So one's going up, one's going down. So we can know the domain here. I can input anything I want to the equation. There's nothing stopping me. So remember, the domain is what we can input into a function. So there's nothing stopping me from putting any number I want. So we write x as an element of R. That R is a fancy way of saying the set of real numbers. So x belongs to any real number. It can be anything other than imaginary numbers, complex numbers, which we haven't talked about. The y's are the same here. Because look at our graph. Doesn't this thing go up forever and it goes down forever? So that means y can also be anything. All right, let's move down the page and look at a couple more. Let's look at the absolute value and the square root function. So the absolute value, what does an absolute value do? I guess if we haven't talked about it before, an absolute value just changes negative numbers to positive. So the absolute value of -5 would equal +5. What if you do the absolute value of +5? What does that output? It outputs 5. So all an absolute value does is if it's negative, it makes it negative. If it's already positive, it leaves it, if it's negative, it makes it positive. And if it's already positive, it leaves it alone. So the absolute value of 0 is 0, right? The absolute value of -10 is +10. The absolute value of +10 is still just 10. So all it does is change negative numbers to positives. If they're positive, leave them alone. So we're going to pick the same starting points, -2, -1, 0, 1, 2. And when we input those into here, the function in this case is absolute value. It changes negatives to positives. So -2 becomes +2, -1 becomes +1, 0, 1, and 2 all stay the same. So Again, I can input anything I want into this. There's nothing stopping me from putting any number I want in. So again, x can be anything. Let's graph this. 0, 0, 1, 1, 2, 2, -1, 1 up, -2, 2 up. And we get this V shape. So I'm going to get out my ruler tool and draw 2 lines. Okay, so now you can see I've drawn my lines. Notice that I included arrows on the end, just like my previous graphs. The arrows showing that it continues, right? Oops. Continues in both directions forever. So we want to include that. If you look back at the previous ones, we also had arrows on those showing it continues forever off of our grid because we've only drawn it on a 10 by 10 grid, but this thing continues forever. Now, inspecting the graph, we can tell that the y coordinates are all greater than or equal to 0. All right, moving on to the next graph, we have the square root function. Now, this is the first one we've encountered where x can't be anything because we can't put a negative number underneath the square root. So that means the smallest number we can put in it is 0. Because again, if we do the square root of a negative, that doesn't make sense. What does that equal, right? So we call that an imaginary number. We're not getting into that. So the smallest number I can put under there is 0. So let's put 0 in and square root it. Square root of 0 is 0. Let's put in 1. Square root of 1 is 1. So far, so good. Now, if I put 2 in, that's okay, but the square root of 2 gives me an ugly decimal number. And that's all right, but wouldn't it be better to just graph nice numbers? So let's skip 2, let's skip 3, let's go right to 4, because the square root of 4 gives us a nice number, gives us 2. Square root of 5, decimal, square root of 6, decimal, square root of 7, 8, all decimals, but if we jump to 9, 3. So those are going to be our key points we use for this one. Oops, 9, 3. We could go further, but the next perfect square would be 16, and that's not going to fit well on our graph, right? So you could include it, but we'll just go with these 4 points here. So 0, 0, 1, 1, 4, 2, and 9, 3. All right, he curves like this. So what this is it's basically a sideways half parabola. So just like our parabolas up above, same idea, but it's a sideways, and it's half a parabola. So it's still got that parabolic shape, but it is turned sideways. So look up here, right? We had a parabola for our quadratic, 2 halves facing up. We had a parabola here, but 1 half facing up, 1 half facing down. And with this one, we have a sideways parabola. And the reason is this is the inverse of a quadratic. That's something we'll talk about later. So now, what about our domain and range of this thing? Well, we just said I can't put anything less than 0 into this. So the x-coordinates have to be greater than or equal to 0. Well, what about the y-coordinates? Let's inspect our graph. If we take a look at the graph, look at the lowest our y's go is 0, and then it goes up forever, right? So the lowest they go is 0, and they go up forever, so the y's also start out being greater than or equal to 0. All right, in describing the shape of the last one, this guy just makes a V shape, right? So he makes that nice V shape. Now, with the square root back to that, notice there's only an arrow on one end. We don't put an arrow here, so no arrow on this side, right? We don't want an arrow over there because it starts at 0. It can't be less than that, but we do want an arrow on the other end. All right, let's take a look at the last one. All right, we're going to do a quick run through of some basics of the next one, but we're going to have to talk about it a lot more in depth in an upcoming video. So let's just zoom in and talk about this guy a bit. All right, so we're going to talk about what's called the reciprocal function. So the reciprocal means basically to flip something, right? So instead of having y equals x, we're going to have y equals 1 over x, right? Y equals x, the reciprocal of that would be y equals 1 over x. You flip it. And again, we'll talk about the family in a future video here. Let's just focus on the parent for now. So this one's a little bit of a weirdo. So let's start with the domain. What can x not be? Well, remember, we can't have a 0 on the bottom of a fraction. That's going to cause trouble, right? That's not allowed. So that means our parent domain, x cannot be equal to 0. You can't put a 0 down there. Now, it turns out that y can also not be equal to 0. Because think about it. What number would you put down there that when you go 1 divided by it would give you 0? In other words, that would give you an output of 0. Like 1 over 1 equals 1. 1 over 2 equals a half, right? 1 over 3 equals 0.3. 1 over 0, we can't do that, so that's out of the question, right? So it's not going to work. There's nothing that will give you a 0. So in this case, y cannot also be equal to 0. Now again, we'll talk about these concepts in a future video. I just want to get the basics down here. So what about our key points? We're going to go with some different key points than the last ones. So what we're going to start with is -2, -1. So far, so good. But we're also going to do -1/2. And what I'm going to do is I'm going to cut this in half. Because when we draw this, we're going to end up getting 2 separate curves. And again, he's a weird one, so he's going to be covered even more in depth in a future video. But let's get the basics started here. All right, and then we're going to use a half, 1, and 2. Now, what happens when I put each of these on the bottom of the fraction, right? 1 divided those. So what's 1 divided by -2, right? That gives me -0.5, or -1/2. What happens when I go 1 divided by -1? I get out -1. What happens when I go 1 divided by -1/2? I get out -2. All right, so we got our first bunch of points. What happens now when I do the exact same thing with these ones, the positive ones? Same thing, but just positive. 1 divided by 1/2 is 2. 1 divided by 1 is 1. And 1 divided by 2 is 1/2. Okay, so we've got our 6 points. Now let's throw those on the graph. So -2 over, 1/2 down. -1 over, 1 down. And -1/2 over, 2 down. Just kind of 3 little clumped together points, right? And a little clump there. I don't know what clumped means. 0.5 over, 2 up. 1 over, 1 up. And 2 over, 1/2 up. So again, we got another little clump of points here and a clump of points there. Now, this is a graph that's going to take a lot of exploration and to really get some important concepts down, but I'm just going to kind of give you the quick run through of the basics of it. So what happens here? If we kept, let's just focus on the positive ones here. If I kept going and did like 3, well, 1 over 3 would be 0.3 repeating. If I did 4, 1 over 4 would be 0.25, right? Oh, sorry, 0.25, not 0.25. If I did 5, right, 0.2, and so on and so forth. It gets smaller and smaller. So as we make the x-coordinates get bigger, it gets smaller and smaller, and it gets closer and closer to 0, but never touches it. So it gets closer and closer to the x-axis, but doesn't touch it. All right, so we can see that it gets smaller and smaller, but it's never going to equal 0. It just gets smaller and smaller and smaller. Well, what if we did it the other way? What if we input super small numbers? So like, what if instead of inputting 1 or 2, what if we, like we did, we inputted 1/2, right? 1 divided by 1/2 was 2. Well, what if I did something like 0.3 repeating, right? Or something smaller, or like 0.25, right? What would I get out? I'm going to get out bigger numbers. So like if I input 1 divided by 0.3 repeating, I'd get out 3. If I did 0.25, right, I would get out 4. So what happens is it gets higher and higher as I put in tinier and tinier numbers. But it just keeps going as I get closer and closer to 0. So what if I just keep hitting smaller and smaller numbers? Like if I input 0.1, I would get out 10. So in other words, as I get smaller and smaller, this thing just keeps going up and up and up. It gets closer and closer to 0 there, right? See how it's getting really close to the y-axis? But it never touches it. So the same effect happens on the other side. This thing heads down infinitely as it gets closer and closer to the y-axis. As you take steps closer and closer, the y values just decrease into the negatives farther and farther. And as you input numbers heading this direction, -5, -6, -10, -100, the y values get closer and closer to 0 from the negative side. So we end up with these two separate curves. So we'll study this in more detail coming up. But that is the basics of it. Okay, you end up with two curves. Now, these curves have something called asymptotes. The asymptotes are the lines that your curves can't touch but get closer and closer to, which starts out as the y and x axis. So our horizontal asymptote is the horizontal line y equals 0. It's a funky looking y. Y equals 0, which is the x-axis. So that's this guy right here. I'll just kind of draw a dash line over top of my x-axis. So that we could label with y equals 0, right? Notice my curves on both sides get closer and closer to it, one coming from the top, one approaching it from the bottom. Now, same thing here. We have a vertical asymptote at x equals 0, which would be our y-axis. So when x is 0, that's our y-axis here. I'll just label it as, oops, a little sloppy here. You get the point. X equals 0. So our curve approaches it from the left and up here from the right. It gets closer and closer to that, but it never actually touches it. Now mine looks like it's touching a bit, but the idea is it gets closer and closer forever without ever actually touching it. So that's the basics we need to just get started before we dive more in depth. So there's 5 key functions that you really want to get to know very well. So make sure you study those and you know those points and how to draw those